Okay, algebra guys. Another section. We just finished learning how to solve equations, or reminding ourselves how to solve equations. They became a little bit more complex. Now we're going to move on to absolute value equations. Absolute value, you guys should already know. It's a very simple symbol. Absolute value. It's those goalposts that are on either side of a number. It just says, they say that absolute value of the number is the positive distance from zero of that number on a number line. So I'm going to show you an example. The absolute value of 3 is obviously 3, right? So absolute value is always positive because we don't have any negative distance. So absolute value of 3 is 3 because it's 1, 2, 3 spaces away from 0. And then over here it says the absolute value of negative 6 is positive 6 because it's 6 spaces away from 0. So if we go from here and we count spaces to get back to 0, we go 1, 2, 3, 4, 5, 6 spaces to get back to 0. All right? So that's really quite simple. And all we're looking for is to take what's inside here, and whatever we find out inside there turns out to be positive. Right now we're just evaluating this expression, this particular expression. See how there's no equal sign over there? It says evaluate this expression if y is a half and z is negative 6. And this is going to be pretty cool. So step one for this and for most is compute inside absolute value symbols. And then step 2, use the order of operations to evaluate. And this will come out to be very, very simple when I show you this example. I'm going to go ahead and input these two values in for my two variables. So I'm going to rewrite the whole thing. I'm going to say 7 times the absolute value of 1/2 times negative 6. And this should be very straight, so we know it's absolute value, we know it's not parentheses. So 1/2 times negative 6, well, 1/2 of negative 6 is negative 3. The absolute value times 7 minus 30. Okay, well, negative 3 inside the absolute value symbols is only 3 spaces away, times 7 minus 30. And so we use, so we've evaluated what's inside the absolute value symbols, and we figured it out. Now we're going to bring it down. We're going to say it's 3, because negative 3, the absolute value of which is positive 3. And now we're going to use the order of operations, which means do the multiplication first and then the subtraction. And so we say it's 21 minus 30. Oh, what's 21 minus 30? That would be negative 9. Do not fall into the trap of multiplying negative 3 times 7 and coming up with a much, much bigger negative in the end. Evaluate what's in here. Compute inside the absolute value. All right? And then show positive value. I guess I should say that, right? Show that positive value of what you got inside there. That's what we did here. So we input our values, we did the operation, we came out with a positive 3, we multiplied by 7, and then subtracted 30, and we came up with negative 9. All right? So give that a shot. I'm going to go over a few. I'm going to give you a bunch to do, so you're going to have plenty of time to work it out. But I want to talk to you about those equations themselves. Now, if you think about it, this side is going to be the same as this side. Well, there are two different distinct values inside the absolute value symbol that'll give us 17, right? There's 17, and there's negative 17, because negative 17 is also 17 spaces away from 0. That's what this absolute value says. So when you have an absolute value equation, and this is the only thing you have there, so far so good, and I'm going to check your work and see if I have to create another video just to show you the other piece. But for now, I'm just going to do this one. So what we do is we solve this 2x minus 3 equals 17. And then we're going to solve for the opposite of that, because that negative 17 will end up being positive, right? So we're going to solve for 2x minus 3 equals negative 17. Now you already know how to do this, and so I'm going to do this very, very quickly because you already know how to solve these equations. You add the 3 to both sides, right? Because we're getting rid of our subtraction. We have 20, and it's going to be equal to the 2x that comes straight down. I'm going to rewrite because that's what I do. So I can perform my operation on it and undo that multiplication with division, divide both sides by 2, and x equals 10. Now we already understood that. We knew that 20 minus 3 was 17. But we want to find that negative value that we can put in to get us to negative 17. By the way, the answer is negative 7, but I don't want to cheat. So let's go ahead and do this first. And we're going to solve the same way. We're going to add 3 to both sides. That goes away. Plus 3. Negative 17 and positive 3 is negative 14. I hope you can see that. Bring the 2x down. Rewrite. I'm just going quickly through here. We're going to still divide both sides by 2. That becomes a 1. X equals negative 14 divided by 2 is negative 7. I didn't know if you trusted me or not, but that's the way it goes. That's the way it works. I'm going to slide out of the way so you can see both of these. This is how you do it. Very simple idea, just two-step equations, and that's it. So just to recap, absolute value is a number's distance from 0. So a negative 12 is 12 spaces away from 0, so we're going to write positive 12. Absolute value just means show the positive value. So when you compute, when you actually do this evaluating inside here and you come up with negative 3, it becomes positive 3, so you can multiply by 7, just like I showed you. And then when you solve equations, if you have the absolute value of some sort of expression here equaling a number, you solve for both its positive and negative values, because if we input that information back in here, we'll come up with 17 and negative 17 accordingly. Any other questions, you'll bring them back to me. I'm going to post a practice page. You're going to do the first column of the expressions, and then I don't know, let's see what's on the back side of it. I'll tell you what else you'll have to do. Here it is. That's not it. And I'm almost there. And yeah, just the first column and the first column. So on the page 24, it's the first column of the expressions. That's every third problem. And then on the back side, it's every odd problem. Thank you.